All right, so this will be a super quick rundown. And I'll post this document on there. I did notice a flaw later on, and I pointed it out. But if you can do the math, that's the main thing. And also, I spoke to a student who already took the ACS for this semester, and he said, "Don't even worry about it. It's not that hard, but still, make sure you study." Okay. Anyway, so here's the original question. A solution of sodium hydroxide is made by dissolving 348.1 grams of sodium hydroxide into 5 liters of water. 258.5 milliliters of the NaOH solution is reacted with 325.6 milliliters of nitric acid solution, made from diluting 450.9 milliliters of a 10.500 molar HNO3 with 378.9 milliliters of water. What is the resulting pH, POH, H plus, and OH minus? So like I said here, to answer this question, let's make it a little easier. Let's break it down into several smaller questions. This is more like you would see it on the ACS if they asked you. Speaking of that, he said there was only like 2 questions regarding the nuclear chemistry stuff. So anyways, all right, so the questions will be in bold, the work will be in red. So here's the first question. What is the molarity of a solution containing 348.1 grams of sodium hydroxide in 5 liters of water? This question was already answered when we did our SI. I typed that. Yeah, this question was already answered when we last SI, but if we need a refresher, molarity is moles per liter. So convert grams to moles and then divide by the number of liters, which is done right here. 340.1 grams of NaOH. Convert the grams to moles, and then you'll have moles per liter, which is molarity. So we got like approximately a 1.745 molar NaOH solution. Next question. What is the resulting concentration when 450.9 milliliters of 10.500 HNO3 is diluted with 378.9 milliliters of H2O? So I went ahead, just because it's safer, I put everything into liters. And it's not super necessary, but it's a lot safer. And it's easy to convert between milliliters and liters. You're just moving the decimal place three places. But okay, so this question asks, and the question is a question in which the dilution equation will be used. In case you need a reminder, here it is. So it's C1V1 equals C2V2, which is the same thing as M1V1 equals M2V2. So then I ask, what is what in this case? So you would look at this and go, okay, my concentration one is this, my volume one is this. We're looking for concentration 2. We're looking for a new concentration since we're diluting it. And we're adding this much water. Now, like the note I made right here, be really careful in this case because it's not just this volume, it's this volume plus this volume right here. So our total volume, our V2, is 0.8298 liters. And like I said, I made a note right there for it. And so when you plug everything in, 10.500 times that divided by that will give you approximately 5.706. I put approximately there because I think I had to round off. I think I put approximately on all of them just to be safe. Okay, so the next part. To save time in doing this, I went ahead and I don't want to say I skipped a step, but this is the kind of stuff that when you're taking your ACS, you should notice these things. If you don't, it's okay. You'd be able to do all the math, but this will save you some time. So, how much H2O can be produced from 258.5 milliliters of a 1.745 molar sodium hydroxide solution reacting with 325.6 milliliters of a 5.706 molar HNO3? And what is your limiting reactant? First thing to notice is the molarity of the HNO3 is much higher, as well as the volume. We have a 5.706 molar solution versus a 1.745 molar solution. Keeping this in mind, it would take way less HNO3 to be the same amount as this. So this is where I said this is the kind of stuff that you guys should notice. On top of that, we even have, it says 325.6 milliliters of this solution. So we even have more of this solution with the higher molarity, which means we have more moles, than we do of the other solution. So if you notice stuff like that, that's going to help you a lot, because when you go to do your calculations, you really only have to do one of the calculations because you know which one's going to be your limiting reactant. So again, like I said, that should signal that the NaOH is your limiting reactant. So going from this, we're going to find what the mass of H2O is. So to do that, we start with our volume. Again, put in liters because we're dealing with molarity here. So 0.2585 liters of NaOH times the molarity will put us in moles of NaOH. Then we need our mole-to-mole ratio right here. And then once we have that, we're going to multiply by the molar mass of H2O, which will give us 8.126 grams of H2O. Now the reason I chose H2O here is because H2O is something that a lot of people already have the molar mass for. If you really wanted to, you would be able to go to NaNO3, which is the other product, right? Because when you react NaOH with HNO3, an acid and a base, you're going to get a salt and water. And the salt in this case is going to be Na, which is Na plus, and NO3 minus, so NaNO3 or sodium nitrate. But since this is one that a lot of people tend to know, I just went with that one. So yes, this will be the mass of H2O that is formed. So now you want to ask yourself, how much excess nitric acid is there? Well, to answer that question, we need to find out how much of our volume of HNO3 was actually used. So we started with this amount. We want to find out how much we used to find out how much excess. So yeah, like I said here, to answer this, we need to take the mass from above and find out how much HNO3 this will use. To find that out, we need to subtract that amount from the initial amount of HNO3. So 8.126 grams of H2O times the molar mass, which I know we could have just written down from right here to find out how many moles of H2O, but people just tend to blow straight through things when they're doing it, including myself. I didn't write it off to the side, so I redid it. Times 1 mole of H2O times the molar ratio, 1 mole of H2O, 1 mole of HNO3. And then this right here is our molarity, the 5.706 moles per liter of HNO3. So that will tell you that you have used 0.075054 liters of HNO3. Now you'll take those liters and subtract from what you initially had to get the 0.2465. Once you figure that out, you'll figure out how much you have left. Once you know exactly what you have left, you can then find out how many moles of H plus you have, because HNO3 is a strong acid. So since it's a strong acid, it's going to completely dissociate. Now right here was where I realized that there is a little bit of a flaw in the situation, because when you react those two, you're producing water, which is what we figured out. So it's going to dilute your solution a little bit, but it's not going to be that much. So I just kind of ignored it. If you want to talk about it later, like I said, talk to me after the SI. If not, then we'll just go through and pretend like that's going to be our concentration of H plus. So like I said, we'll go from here, this many liters times the molarity will give us this many moles of HNO3, and then the concentration of HNO3 is going to be the concentration of H plus, which is 1.407 molar. So that tells you right away your pH is basically going to be 0, your pOH is basically going to be 14, and your OH minus is almost non-existent. So if you look, when you do the actual calculations, these are the numbers you would get though. Negative 0.1483, negative 14.1483, and then 7.107 times 10 to the negative 15. Yeah, so I'll post this and then let me know if you guys have any questions. All right, bye.